done the Anthe revision. Then let's recap all the chapters. So first let's start from number systems. It is from the subject of maths. Okay, so in the number systems we are going to just do what are the important things we need to perform during this chapter. So there are different types of numbers, by the way. So there are natural numbers, whole numbers, integers, rational numbers, irrational numbers. So natural numbers are those numbers when we count. So suppose if we are playing any hide and seek game, so suppose we count. So we just start from 1. So we don't start from 0, right? So the counting numbers, so they are known as natural numbers. And then they are denoted by letter N. Whole numbers. The when we add 0 to the set of natural numbers, then it is known as whole numbers. It is denoted by letter W. Integers. The set of negative numbers which is added towards the set of whole numbers. They are known as integers. Rational number. Any number in the form of p by q where p and q are integers and q is not equals to 0. It is known as a rational number. So, by the way, if we find all these four areas, so we can find that every natural number is a whole number, every whole number is an integer, every integer is a rational number. But in the next set, it will neither be a rational number, will neither be an irrational number, or these all four sets will not even come under irrational number. They are non-repeating decimals, where there are non-terminating and where they are having non-repeating also. So we mentioned there 3 dots after the decimal. Okay, so it's very important as mentioning the 3 dots. Okay, the real numbers, the set of natural numbers, whole numbers, integers, rational numbers, and irrational numbers, which are combined. All these numbers come under real numbers. Okay, so for now, let's know. Let's see how can we do. So, for example, if we are given here as a number, we are given to rationalize this following number: 2 plus 3 divided by root 7 minus 3, root 3. Okay, so I'll just give here. So suppose if you are given like this, see, when we are given this one to what do you tell, rationalize, we need to rationalize only denominator. So what we need to find? We need to find the additive inverse of root 7 minus root 3. So which implies root 7 minus root 3 can be root 7 plus root 3 by root 7 plus root 3. The main rule is that for rationalizing this denominator, we need to mention in the next one for multiplying numerator and denominator both at the same additive inverse. So because in order to rationalize, it will be easier. So when you cross multiply, we get root 7 minus root 3 into root 7 plus root 3. So which implies we get root 7 squared. Root 7 squared. When we cancel this and this, we get here as root 7. When you cancel the square one and the square root, we get here as 7. And then when we are given here as root 3, so minus root 3 into plus root 3, which implies the same numbers, so which will become 0. Okay, so and then we need to multiply with the other one. What do you tell? We got 2 plus 3 into root 7 plus root 3. So if you are given here as root 3 plus root, first let's multiply with 2 root 7 and then 3 root 3. The solution I have got here is 2 root 7 and then 3 root 3. The solution we get is going to be 14 root 7 squared, which will be 14 into 7 plus 3 root 5 plus 3 root 5, where we get the solution as 98 plus 3 root 5. And here we have rationalized the denominator. So here we can't find the denominator as the irrational number. So we can just directly make here as an additive inverse of the second digit, where the minus digit should be plus or plus digit should be minus. In the next one, we need to make it as a convert it into a fraction in the both. Like how we make it as a equilateral fraction. How do we convert? So like this, we just need to add here the plus symbol, opposite symbol of the symbol which is given in the question. Okay, so now let's try to find. We have seen how do we rationalize the denominator, and then let's check the identities also, the loss. The spiral chord and irrational number on a number line is deleted currently. Let's see the exponent loss. Okay, so when you are given here as a particular one, like when you are given here as a to the power of m plus a to the power of n, the solution will be a to the power of m plus n. The solution of a to the power of m plus a to the power of n will be a to the power of m plus n. This is the law number 1. Next one is when you are given here as a to the power of m by a to the power of n. So which implies we get here as a to the power of m minus n. It's just the vice versa of the fraction which we get in this. So if you are given two powers with the same whole number, this is this is the uh, this is the power, and then there is the constant. Okay, so when you are given as the same constant, then we need to subtract the two exponents, and then we'll get the solution. Okay, so we are given here as like this, and then the simplified solution will be a to the power of m minus n. This is going to be the law 2. Law 2. The law 3 is that when you are given a to the a into b. Daddy. Namaste. So today we are going to learn. Let's continue. When you are given here as a into b whole to the power of m, and the solution will be the third law consists of a to the power of m into b to the power of m. That's the main rule. Okay, so if you are given a into b whole to the power of square, so what we need to do, a square into b square. Example. This is known as third law. Now let's do the another one. Now what all we have discussed, let's find. So when you are given as a to the power of m into a to the power of n is equals to a to the power of m plus n. Law number 1. A to the power of m by a to the power of n is equals to a to the power of m minus n. Law number 2. A into b whole to the power of m is equals to a to the power of m into b to the power of m. Law number 3. Now you are given like this. A to the power of m by b to the power of m. Okay, so when you are given this one, now like this you need to do a short this one. When you are given This is given as like this. So which implies ai by b whole to the power of m. A by b whole to the power of m. This is the other law. Okay. So now let's try to continue. Now with this, we have completed this main laws. Now there's some change in these laws for this year. So now we are given all these laws, right? So now how can we change? The small change is that before that, let's continue the incompleted one. So a to the power of 0 is equals to 1. Any number with power of 0, always it is going to be 1. Okay, it's going to be always 1. And then now if you are given a to the power of 1, the solution will be a itself. And that's all. We get the answer. Now let's try. Okay, so when we are given like this, now just what we need to do is that we need to add root everywhere. Root. Okay, so now we are given here a to the power of m into a to the power of n. A to the power of m plus n. Next, a to the power of a to the power of m by a to the power of n. We get the solution as a to the power of m minus n. Okay, so that's all. Let's do this. The main difference is that we are just going to add here roots. Okay, we are just going to add here roots. We are just going to add here roots in place of these laws. Okay, only the short difference for this here. The solution will also be calculated as root only. So something like this. That's all. So we have completed our identities of these number systems, and then we'll move forward towards the polynomials. Okay, so now let's move forward to the polynomials. Polynomials is a chapter where we'll complete it a bit more fast. What do we mean by polynomial? There's a short difference between a polynomial and an algebraic expression. Okay, so the short difference is that uh, in a polynomial, what do we do? It is referred as, why is polynomial referred as p into x? So to just know in details, p is referred as polynomial, x is referred as a variable. Now we are given as p and x. We have found the value. What is the meaning of p and x? So now suppose we are given this. We are given ax a. It's a monomial. We are given ax plus b. It's going to be a binomial. Why? Because a is having only one variable or one unit, and x plus b is having more than one unit. Means it has having two units. So it is referred as binomial. When we are having ax plus b plus c, where it has three units, it is known as trinomial. So when you add here as ax plus b plus c, it's a trinomial, and with this trinomial, what can we do? When you are having four or more than that, so let's take ax plus b plus c plus dy, something. It is having four or more than four, is known as a polynomial. Terms, they are only terms. We are just classifying these terms. Now we are having the what do we tell? Now let's try the short difference between a polynomial and an algebraic expression. In a polynomial, we are going to have uh, we are not at all going to have this denominator a variable. That it is known as an algebraic expression. Suppose, now let's leave. Now, if you are given here, this is known as an algebraic expression where y, x, y, and z are the identities, variables. The variable should not be placed in the denominator, the main rule. So let it be in the form of square root, something, something. So we should not place the variable in the denominator. Okay, finished. Now, algebraic expression, it can be in any form, whether the variable be in denominator or numerator. There's no change. Only the short difference makes the polynomial as a polynomial, expression as an expression. That's all. Okay. So now let's find something new. Here, if this is like this, ax plus b. Okay, so wait. I'll just change it. Ax plus b plus c is equals to 0. It's something. It's a polynomial where you are having no variable in the denominator. Only variable. Number can be there, but no variable in rule. That's all. Okay. So now we have found what's the meaning of a polynomial and an algebraic expression. Now let's try to find some new thing. Uh, let's find these identities. Okay, for finding these identities, required to plot the graph. Okay. So now let's take a line. So just draw a line where we are required to draw. So we are given here a 0 and 1. Where is 0? So for 0 we can't plot any line. So it's in the line itself. So you can directly plot 1 as this. This is a 0 and then 1. We can directly plot it as a 0, 1. It's a coordinate number 1. So we can directly plot it here. It's going to be 0, 1. And it is more safe. The main point is that when you are given 0 and 1, where 0 is given, if 0 is given first, then you need to plot it at means x-axis. If you are given 0 is at last, then you need to plot it at y-axis. So this is for y-axis and this is for x-axis. Okay, so see, it's for 1 0 and it is 0 1. And now we are given 2 and 3. We need to plot 2 and 3. So first what we need to do, where is 2? Just take that line a bit more forward. And where is 3? Just take this line a bit more forward. Okay, so now when you are given the point of intersection is 2, 3. This is a 2, 3. You can directly point at this one, intersecting one. Okay, that's all. So we can directly plot like this coordinates, and then that's all. This chapter is finished. Now let's start with linear equations in two variables. So what do we mean by linear equation? What do we mean by an equation? So let me tell you. What do we mean by an equation? Which equation? Okay, so what do you mean by an equation? So equation is nothing but mix of variables and the numbers to get a definite solution. So when we add variables and numbers to get a definite solution, variable is represented by any letter. We can make any letter as a variable in maths. So suppose we know the standard form of linear equation in one variable. So standard form of linear equation in one variable is of a linear equation in one variable. It is ax plus b is equals to c. So means we'll get a particular solution. We just need to find with RHS and LHS. We need to just simplify and then we need to just change the signs and then we'll get a solution. Now this year we are just going to learn linear equations in two variables. So there are different types of equations. One is linear equation. Second is quadratic equation. Third is biquadratic equation. So like this, we are having the different types of equations. So if we are having quadratic equations, then it is something different, uh, and then biquadratic is also different. So we are having right now we are currently learning only about linear. So linear equation in two variables, standard form. So we are just given here as it is represented as ax plus by plus c is equals to 0, where a, b, and c are numbers and then x and y are variables. Or else you can make it as x plus by is equals to c, something. Okay, so like this now we are given what is a linear equation and something. We have found what is a linear equation, what is the standard form. So now let's try to solve. Suppose you are given 2x plus 5 is equals to 7y. You are required to find the solution of this. So which implies you need to find the two coordinates. It's like a coordinate one, x, y. Find the value of x and y. So now you need to just make it as LHS and RHS. You need to just change this solution like this. So you are given here as 2x minus 7y because the symbol is changed from left to right and right to left. The addition to subtraction. Minus 7y is equals to minus 5. Okay, so you are given here as minus 5y equals to minus 5. Now consider x as if x is equals to 0. Something if x is equals to 1. Then the value will be 2 into 1 minus 7y minus 5. Now here we are given here as 2 minus 7y. Okay, so now 7y is equals to minus 5 plus 2. Minus 5 of minus 2. So minus 7y is equals to minus 5 minus 2, which implies minus 7y is equals to minus 7. So which implies 7y is equals to 7. Implies y is equals to 1. Finished. We got the solution of the EC equation. Something like this we can directly plot. So this is one of the equation where we can solve. So this is an example. So let's try to plot an equation. So suppose we are just given like this. So we just need to plot an equation. We'll be getting some two solutions or three solutions into plot it in a graph using the coordinate geometry chapter. Okay. So you need to find the three approximate solutions. So you are given as x plus 2y is going to be 3. Okay, so if x is going to be 1 and y is going to be 1, it is going to be 1 plus 2 into 1, 3. 1 plus 2, 3. Now if you are given x is going to be, if x is going to be 3, y is going to be something like 0, which implies 3 plus 0 is equals to 3 because 2 into 0 is 0. Okay. So 3 plus 0 equals to 3. So we got the solution for this also. Okay. So now this you can, now let's try to plot this in a graph. So we got 3 0 1 1. Let's plot it. So we are given here as 3 0 and 1 and 1. Let's take these quadrants. Okay, so here we are given as a coordinate geometry. So let's change this. So just we need to add the variables and then we need to just convert it. So now we are given here as this 2 1 and 1 and 3 and 3, 3 and 0. Okay, so now let's plot this here 1 and let's plot this here 1. This is going to be correct, and then now here we are given here as 0. So now let's plot this as 0 3 0. Okay, so now we can directly mark it here as 3 0 1 and 1. Now what you need to do is you have plotted, so just draw a line where it should intersect these two. I have drawn right, so just combine this line, just make this arrow, and then you need to make the equation what you have given. So you are getting as x plus 2y is equals to 3. And that's all. The solution is given, and that's all. You can plot so many like this graphs. And with this, the linear equations is also finished. Now let's try to find the other chapter. Okay, so let's find, we have completed this linear equations, and then now we need to find something. Is there any other chapter left over? Lines and angles and triangles. So we are left over with those two chapters. Now what do we mean by a line? To know the basics, this is known as a point. Okay, so a point which does not have any particular definer, but it has a sharp edge, it has a sharp dot, it is known as a point. Okay, so when you are having a fixed distance, it is known as a line segment. When a line can start, when there's a starting point and there's no ending point, it goes on continue, then it is known as a ray. So let me tell you that ray will have like this arrow, but line, there's no ending point, there's no fixed distance, only continuation, no starting, neither starting nor ending. Okay, so it will neither have a starting nor an ending point. So the combination of points, when you just make this point dot, when you just continue these points and no break is there, then it is known as a line. And then when there's a starting point and there's no ending point, this is known as a ray. When there's only a fixed distance, starting and ending is there, it's a line segment. When there's no starting or where there's a dot, it is known as a point. That's all. So now let's learn about this all in a short manner. So something like this, lines and angles. Yeah, select. Now let's take it as if you are given an angle. Okay. So if you are given an angle, uh, you are given something like this problem to solve. Okay. So now you are asked that this is a particular x, and this is going to be a x. How can you prove? This is the one more thing. And then now you are required to find here as it is going to be uh, a divisor. It is going to be also x. And here the other angle is going to be 14 degrees. Now how can you find the value of x? So this is the rule. So suppose now with this I'll just tell you the opposite angles are always going to be equal. When this angle is equal, this is also going to be equal. Why? Because of opposite angles, vertically opposite angles. Okay, so when this angle is equal, this angle will also be equal. Why? Because of vertically opposite angles. Now, when you are given this and this, how are they equal? Not. It's because same side of a transversal. Same side of a transversal. X. Done. Now even here also it is going to be 14. Okay. So now here also it's going to be 14. Same like this. Because of vertical opposite transversal, and then linear pair is also going to be used. Why? Because when there are two angles where they are intersecting, and then the sum of them is going to be 180 degrees. Why? Because they are at the same line, but the sum is going to be 180 degrees because it is going to be a linear pair. So it is known as a linear pair. Okay, so 14 plus x is going to be 180, and then x is going to be 180 minus 14, and then which implies uh, here we have given here. So x plus 14 is going to be 180. So 180 is going to be 180 minus 14 is going to be x. So which implies uh, going to be 166 degrees. Okay, so the value of x is going to be 166 degrees, and then here we have found this is a vertical opposite, same side on a transversal, and then this one is going to be an alternate interior angles is going to be this. When there are two angles which they are going to be alternate, this and this is going to be equal because of alternate, and then this and this is going to be equal because of alternate. So the value of x is going to be 144 degrees, and hence we have proved the solution is going to be x value is going to be 166 degrees, and that's all. We have learnt all the types where we can find the solutions. So now here our lines and angles are also finished. Now let's find triangles. Now we are given to find about triangles. So what do we mean by triangle? So triangle is a least sided polygon. Okay, so the least sided polygon is known as a triangle, where the triangle has only three sides. Okay, so a triangle has only three sides. We know it from the earlier classes. So these three sides, the least sided polygon is known as a triangle, and then the triangle has many properties. When the sum of the angles sum up to of a triangle sum up to 180 degrees, this is known as an angle sum property. Angle sum property refers to the sum of the angles is going to be 180 degrees. Okay, this is called as an angle sum property. This is going to be 180. This is going to be 180. This is going to be 180. Now, to find two triangles should be congruent. How can we find? So we can just directly find it as, you can just find that these two triangles are going to be congruent because we can find that this congruence these triangles are going to be congruent, and then we can find how can this be congruent. So in order to find, there are some criterions where we can find that these triangles are going to be congruent to each other. Okay, so first criterion, when there are all the sides of a triangle are equal. When all the sides of a triangle are equal, then the triangle is said to be congruent. Okay, so now when we tell that when we are given two sides and an angle at these sides, at that time also the triangle is said to be congruent, but in a different criterion, side, angle, side. First criterion is SSS, which is side, side, side. Second criterion is side, angle, side, SAS. Now third one. Uh, the third criterion is going to be ASA. When you are given two angles and a side, and then they are going to be equal, congruent, with a criterion of ASA, angle, side, angle. Okay, so we are we are given one more criterion, but that is not going to be there. When we are given two angles and a side at different one, we are given two angles and a side. Then this is known as an AAS criterion. This criterion is not there. Okay, so these are the criterions where we have learned till now. So the angle sum property, these some of the angles is going to be 180 degrees and etc. Now with this we can find that when these triangles are going to be congruent, we can tell the other sides are also going to be equal because of CPCT. The CPCT means corresponding parts of a congruent triangle. Okay, CPCT means corresponding parts of a congruent triangle. Okay, so the corresponding parts of a congruent triangle is known as a CPCT. Okay, so this is known as CPCT. We have learned about angle sum property, the how the triangles are going to be congruent, and the transversals and etc. And with this maths is going to be completed. And now let's start with science. Okay, so with science, let's start with motion. So now in order to know motion, what do you mean by motion? Motion is something when an object is not at rest. So when we tell an object is in motion, when an object starts moving from its origin, and when an object does not move, it is known as it is in the rest. When an object starts moving, it is known as it is in the motion. Okay, so suppose if you are given here an object is at rest when it is not moving. The object will is in motion when it is having some movement. When it has some movement, right? So now with this, we know what how an object has a motion when it has some movement. Now, in order, there are two types of quantities: scalar quantity and vector quantity. And vector quantity. And vector quantity.
2019.
Okay, so the vector quantity and scalar quantity. So the scalar quantity, the type of motion which has only magnitude, is known as a scalar quantity. Vector quantity has both magnitude and direction. It is known as vector quantity. The scalar quantity examples are speed, distance, etc. Vector quantity is going to be uh, displacement, force, etc. Now, how can we measure vector quantity? So, if we are now, let's know we have known the different types of quantities. Now, let's find what is going to be a distance and a displacement. A distance is something the total length covered by an object. Okay, the total length covered by an object is known as a distance. Displacement is going to be the uh, displacement is going to be the total shortest distance by an object. Okay, so distance is a scalar quantity, displacement is a vector quantity. Okay, so now to find a displacement, when we are when we say that an object is in circular motion, there are different types of motions. So first is rectilinear motion, an object is in straight line, and there is oscillatory motion. When an example of pendulum clock, when it starts from means and extremes and once again back to means. So this is known as a oscillatory motion, and then circular motion is when an object moves around a circular path. It is known as a circular motion. And then the uniform motion. Okay. So the uniform motion is referred as when an object moves at an equal distance. An object moves at equal speed at equal intervals of time. The correct example is going to be the clock. Because it moves at an equal speed. It does not move so fast or it does not move so slow. It moves at an equal speed. And then this is known as a uniform motion. Non-uniform, it does not move at an equal speed at equal intervals of time. Okay. So the examples of uniform motion are this clock and etc. Now non-uniform. Now let's learn what is going to be an acceleration. Acceleration is something when an object, the rate of change of velocity. So before knowing this acceleration, let's know what is the velocity. Velocity is something. It is related to speed, but it is the shortest one. It is a vector quantity. It's a vector quantity related to speed only, but it's a vector quantity. But a vector quantity. But the SI unit of velocity and speed is going to be the same. Meter per second. The velocity of acceleration is going to be meter per second square. Okay, so with this we have made about velocity and acceleration. Acceleration is something uh, when we try to change the speed. It is known as an acceleration. The rate of change of velocity is known as an acceleration. The rate of change of velocity is known as an acceleration. When you change the velocity. So acceleration is a vector quantity, velocity is also a vector quantity. Okay, so we can find the acceleration using this, and that's all. Now let's see how can we calculate the distance. If we are given a speed, if we are given a speed, then we can directly and the displacement, then we can directly calculate the distance, which is speed into displacement. Okay, speed into the particular displacement. If we are given to calculate the dis speed, means distance is speed into time. If you are given to calculate the distance for means if you are given to calculate the velocity, then it is going to be displacement into time is going to be velocity and same, etc. And with this, we have completed the motion chapter as well. Now let's start with force and laws of motion. Now force and laws of motion. Before knowing the laws of motion, let's know about the force. What is going to be the force? Okay, a force is something uh, where an push or a pull is applied to an object. It is known as a force. SI unit of force is Newton. Is Newton. And so when you are given as SI unit of force is Newton, and then there are three laws. First, law of inertia. Second, second law, and then the third law. Newton's there are Newton three laws, and then we are given as force. So to calculate force, we need. So the formula for force is mass into acceleration. So what do we mean by mass? Mass is the particular rate of of a particular object. So like it's measured in terms of kg. Okay, mass into acceleration is known as force. Now the laws, there are three laws of motion. Law number one: every object moves in a straight line unless acted upon by a force. See, a car moves front. It only moves in a straight road, does not turn anywhere. Suddenly, if a bus hits a car, then car suddenly stops. So the force is applied. So at that time, this first law is correct. The acceleration of an object is directly proportional to the net force exerted and inversely proportional to the object's work. So this is the second law. This law states that the an object which is having an acceleration is directly proportional to the force exerted and inversely proportional to the object's mass. Okay, so the third law. For every action, there's an equal and an opposite reaction. So suppose if we are throwing a ball, so gravity tries to pull it down, but we are trying to pull it up. There's an equal action, positive, then there's an unequal action too, negative. So this is also an example. So this is about the force and laws of motion. So these are the main laws, and then now let's learn about gravitation. Now we have completed with gravitation, and physics will also be finished. And what do you mean by gravitation? So gravitation is something like and everywhere the same law is used. So there's a particular constant. There's a gravitational constant where G is equals to mg mass. G is the gravitation is equals to 6.67 into 10 to the power minus 11. See how small is the gravitation? Very small, right? The value of g. This is known as a universal gravitational constant. Okay, gravitational constant is 6.67 into 10 to the power minus 11 Newton. Newton. The main rule is that Newton kg per meter. Kg square per meter square. Okay, kg square per meter square. Okay, so that's this is known as a gravitational constant, and then we use this for a lot of purposes. Okay, so now g. G is known as acceleration due to gravity. It differs a lot. Capital G is always constant, small g always differs. When you are given a small g, it's known as acceleration due to gravity. Okay, the value of small g is very different. At the center of the earth, the value of small g is 0. At the surface of the earth, the value of small g is 9.8 Newton. Okay, and then there is a centripetal force. The moon revolves around the sun at a particular area. It's known as centripetal force. Centripetal force is the moon revolving around the earth in a circular path. Is known as a centripetal force. And that's all. We can directly calculate how much our height if we are given to find the height. So the same there are some motion laws. Okay. So you just remember the motion laws and then you'll get directly. Okay. Initial velocity is going to be. I have did not tell any laws in the motion one, so I'll just give a brief introduction and then you can directly replace the values with g and h. Okay. So the formula for force is mass into acceleration. So what do we mean by mass? Mass is the particular rate of of a particular object. So like it's measured in terms of kg. So yeah, mass into acceleration is known as force. Now the laws, there are three laws of motion. Law number one: every object moves in a straight line unless acted upon by a force. See, a car moves front. It only moves in a straight road. Does not turn anywhere. Suddenly, if a bus hits a car, then car suddenly stops. So the force is applied. So at that time, this first law is correct. The acceleration of an object is directly proportional to the net force exerted and inversely proportional to the object's work. So this is the second law. This law states that the an object which is having an acceleration is which is directly proportional to the force exerted and inversely proportional to the object's mass. Okay, so the third law. For every action, there's an equal and an opposite reaction. So suppose if we are throwing a ball, so gravity tries to pull it down, but we are trying to pull it up. There's an equal action, positive, then there's an unequal action too, negative. So this is also an example. So this is about the force and laws of motion. So these are the main laws, and then now let's learn about gravitation. Now we have completed with gravitation, and physics will also be finished. And what do we mean by gravitation? So gravitation is something like and everywhere the same law is used. So there's a particular constant. There's a gravitational constant where g is equals to mg mass. G is the gravitation is equals to 6.67 6.67 into 10 to the power minus 11. See how small is the gravitation? Very small, right? The value of g. This is known as a universal gravitational constant. Okay, gravitational constant is 6.67 into 10 to the power minus 11 Newton. Newton. The main rule is that Newton kg per meter. Kg square per meter square. Okay. Kg square per meter square. Okay. So that's this is known as a gravitational constant, and then we use this for a lot of purposes. Okay. So now G. G is known as acceleration due to gravity. It differs a lot. Capital G is always constant, small g always differs. When you are given a small g, it's known as acceleration due to gravity. Okay, the value of small g is very different. At the center of the earth, the value of small g is 0. At the surface of the earth, the value of small g is 9.8 Newton. Okay, and then there is a centripetal force. The moon revolves around the sun at a particular area. It's known as centripetal force. Centripetal force is the moon revolving around the earth in a circular path. Is known as a centripetal force. And and that's all. We can directly calculate how much our height if we are given to find the height. So the same there are some motion laws. Okay. So you just remember the motion laws and then you'll get directly. Okay. Initial velocity is going to be I have did not tell any laws in the motion one, so I'll just give a brief introduction and then you can directly replace the values with G and H. Okay. So now let's see the formulae for motion. So the main formula for motion is speed is equal to distance by time. The average speed is going to be the total distance traveled by total time taken. Average velocity is going to be the total displacement by total time taken. Acceleration is going to be final velocity minus initial velocity by time. Final velocity is going to be initial velocity plus acceleration into time. And the distance is going to be initial velocity into time plus half acceleration into time whole square. When when u is equals to 0, means final velocity is going to be 0, then this is equals to half at square. Okay, so v square initial velocity minus final velocity whole square minus initial velocity whole square is equals to 2 into acceleration into distance. When a body starts at rest, initial velocity is 0, then final velocity is the acceleration to time. Displacement is a half at square. Initial velocity square is equals to 2as. And then when a body is moving in uniform motion, uniform retardation, v is equals to u minus at, s is equals to 2 minus half at square, and then v square minus u square is equal to 2as. And then with this we have learned the formula of motion, and then with this the physics chapter is finished. And then let's start with chemistry. So now with chemistry, I think this is going to be a best chapter. Something is going to be a better and an easy chapter also. Okay, so let's start with chemistry. So before starting with chemistry, let's take a short are having chemical and compound. In element, we are having the gas elements like hydrogen, carbon, and etc. In the compound, we are having the mixture of many substances, and it is not so pure. So in that, we are having few substance. Few substance is having uniform composition, whereas impure having the non-uniform composition. And with this what do we tell is that in this it's matter around us the homogeneous and heterogeneous mixtures are homogeneous is uniform, heterogeneous is non-uniform. So that is all is about matter around us pure. And then we have completed here. With this we have done our matter around us pure. And then now let's do this one. What is atoms and molecules? So what is an atom? The smallest part which is lower than atom is known as an atom. So there are different types of atoms like hydrogen, carbon, lithium, beryllium, and etc. So in these atoms, these were being discovered by some other people, J J Proust and Dalton and etc. J J Proust and Dalton and etc. And then now right now we'll this one. What do we tell means we'll right now find the Dalton's atomic theory. So in the Lavoisier, he has found the law of conservation of mass, and then the other person has found the law of constant proportion. So now let's find both have been found by the Lavoisier. Both have been found by the Lavoisier. Okay, so and then now let's find uh, how did Dalton has made everything as unity. So he has made it into an six postulates, Dalton's atomic theory. Out of that, law of conservation of mass, law of constant proportions, they all combine into the small whole numbers is a law of constant proportion, and then conservation of mass is a particular mass. So the atom has a particular mass, and then let's see the Dalton's atomic theory. So in this Dalton's atomic theory, we have six postulates. Okay, so they are uh, all matters consist of indivisible particles called atoms. Atoms of the same element are similar in shape and mass, but differ from the atoms of other elements. Atoms cannot be created or destroyed. Atoms of different elements may combine with each other in a fixed, simple whole number ratios to form compounds. These are some of the Dalton's atomic theory and etc. So now, right now, we need to find how do we frame the equations. Okay, in order to frame the equations, we require the means there are different types. So we are having one single chemical compound atom. It consists of it exists, but example like nitrate, potash, nitrate, hydroxide, they are not having any singular compound. Like if you are taking oxygen also, it does not have a single atom, it needs two atoms. So it is going to be oxygen gas, is going to be O2, O3 is ozone, so nitrate is NO3, where it is not having any singular element. So there are different valencies also in order to find. And then just remember the valencies. And with this, the chemistry is also finished, and then we'll complete the biology part also, and then we'll complete this small revision. Okay, so in this biology one, let's take what is the fundamental unit of life. The fundamental unit of life. What do you tell? What is the fundamental unit of life? It is a cell. Cell is a structural and functional unit of life. Okay, so with cell there are the two types: unicellular, multicellular. Unicellular are these organisms which require only a singular cell. So example is amoeba, bacteria, and etc. The multicellulars are the more than a single cell, means like trillions and trillions of cells are required for human being, and it depends upon the organisms. So in the plants, animal cell, it is known as eukaryotic, and in the animal cell it is known as the eukaryotic, and in the plant cell it is known as the prokaryotic cell. And with this, the main difference between the plant and animal is plant cells have uh, two types, that is meristematic tissues and permanent tissues. In meristematic tissues, there are in plant cells there are different types. You'll learn about more than in tissues. Okay, so the many cells comprising same particular task is known as a tissue. Okay, with this fundamental unit of life is also completed, and then we'll complete these tissues. Okay, the tissues. What do we mean by tissues? So tissues is something where we tissue. So the group of cells performing the same task is known as a tissue. So there are different types of tissues in plants. There are two types, that is meristematic and permanent. Okay, so it is meristematic and permanent tissues. In animal, permanent. Okay. So in this meristematic tissue, it is also known as a temporary tissues. In this temporary tissue, there are different types. Okay, apical meristem, lateral meristem, intercalary meristem. In the apical meristem, it is used for the growth, primary growth. Okay, so it keeps on dividing. It is like a rapid fire. It keeps on dividing. Okay, and then in the lateral meristem, it is used for the secondary growth, and in the intercalary meristem, it is used for the growth in the third growth, which will spread the stem, which will make the stem fat and etc. And then with this These are the two types. In the permanent tissue, there are two types: simple permanent and complex permanent. In the simple permanent tissue, there is going to be in simple permanent tissues. So in the simple permanent tissues, there is going to be the three types: parenchyma, chlorenchyma, collenchyma, sclerenchyma. Parenchyma are two types. That is sclerenchyma, and we are having the meristematic tissues, and then the permanent tissues we are having the parenchyma. Parenchyma is the leaf bud of the plant where we are having only in this parenchyma we are having only the particular function where the outermost leaves, which consists of leaves and buds. Um, and then with the next one we have is collenchyma. In the parenchyma we are having chlorenchyma also. In the chlorenchyma we are means it contains of chloroplast, so it contains only chlorophyll in it, so that's all. And then in the sclerenchyma the cells are dead, and then the complex permanent tissues there are xylem and phloem. Xylem consists of scleron, parenchyma, and etc. And then phloem is also it consists. This both complex permanent tissues consist of major works. And then with this the tissues chapter is finished, and then finally is why do we fall ill. In this why do we fall ill, there are different types of diseases: acute diseases, chronic diseases. In these acute diseases there are short period of time diseases, and the chronic diseases are the long period of time diseases. So in this acute diseases the example is fever and a cough and cold, etc. Chronic diseases is cancer, diabetes, tuberculosis, and etc. So the chronic diseases makes a lot of problems in our life. It will be with a lifetime, where acute diseases gets reduced in a very short period of time. So with these diseases, types of diseases have been compared. What do we mean by vaccination? Vaccination is something which provides immunity to our body, and then it reduces the diseases. Okay, and then with this, the YDF College is also completed. And all the best for the Anthe exam, and do your best. And have tried to revise almost all today, and then I will send the figure matrix. So suppose you are given a triangle with the figure matrix. Okay, with the figure where you are given different triangles. So in those triangles, you are given to count the triangles. In triangle and triangle, inside there are many triangles and triangles. So in those triangles what you need to do is that you need to uh, means means in this triangle you are going to do with the maximum inner and means in this triangles you are going to calculate the triangles number of triangles plus with the total number of into plus the number of triangles you just counted. Okay, and then with this into multiplied by 2. Okay, the solution will be given. Okay, like this you can follow some short tricks, and then thanks for watching, and all the best for your Anthe exam. Thank you.